This is section 2.3, Universal and Existential Quantifiers. We're going to be learning a little bit more about logical implications and the terms and symbols that we use to show these implications. Right, going off of the idea of if condition A, then condition B, right, we assigned a truth table to that. We're going to show various ways of writing such things. So first, a couple of symbols that we frequently use. If we ever use a backwards capital E like that, that means there exists. If we're ever talking about an element of a set, we might say there exists an element of a set. We might say something like there exists X in big X or something like that. I use ST to mean such that, right? Just there exists an X in X such that it has some property, right? So that's just one example. Upside down capital A means for all, right? The opposite of there exists in a sense, right? Because it's saying for all, for example, for all X in X, some property holds, right? It could be something like that. You're probably familiar with this term that means implies. Remember that double-sided implication, right? It means the implication goes both ways. It also means if and only if, right? So yeah, implications, right? And then that symbol right there means and, that symbol right there means or, okay? So if we wanted to translate the following sentences to English, we would say, if there exists A in X, just to be clear, that's A in a big set X, then there exists B in Y, right? And just to be crystal clear, this becomes this, that becomes that. Okay. And then here, this is one. There exists A in X such that, or, satisfying, such that for all B and C in Y, we have B is less than C. Now you might say, why did I put the word we or words we have in there? Well, because I don't like this. I don't like punctuation followed by math symbols. I think that's confusing. Okay? But anyway, hope you see this is this. That is that. Okay. Anyway, moving forward, look at this. This is a long one, right? For all elements A in X, there exists B in Y such that, oh boy, I need to move this a little bit more. A plus B is in Y, or A minus B is in Y. Okay? All right, and again, just to be crystal clear, here's our for all. Here's our there exists. Here's our and, or our or rather. And there we go. All right, and then last but not least, we have if S is a subset of the natural numbers and S is not, we could just say, we could write it like this. If S is a non-empty subset of the natural numbers, and, oh no, sorry, we don't need the and anymore. We can just say this. Then there exists X in S such that for all Y in S, we have X is less than or equal to Y. So again, right, this thing, right? This is a thing, but I feel like this, maybe I don't write the if part, right? This is just a nicer way of writing it in words, right? And then, of course, the exists, right? Just kind of follows here. For all, right, etc. Okay. Anyway, we can go the other way, right? Now, in general, this is an exercise. Example 2 is an exercise. In general, I want you writing things using words. You can write symbols like X is in X when it's appropriate, but in general, try not to write the for all and exists signs unless I ask you to. Okay, but anyway, it's good to be fluent with this stuff. So we could write something like this. Right, you see that? See how we translated this guy right here, this guy right there. Let's keep going. There exists a natural number m such that for all n in the natural numbers, I guess we don't even need to do this. Right, so we have that. Right, again, exists, there exists. For all, okay? And then the last one, for all real numbers are, all numbers R and S, there exists rational number Q, right, big Q is the rationals, such that R is less than Q is less than X, or S, whatever. Okay? And just to be crystal clear, for all exists, blah, 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 right? Okay, great. We also can negate a statement that makes it the complement of what it used to be. It makes it not what it used to be, right? Now, sometimes if I were saying, X is an element of big X, and we negated it, we would write X is not an element of X, right? We just draw a line through it. You could do that, right? You could say there does not exist, blah, 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 blah. But sometimes that's not very informative. Sometimes you want to be a little bit clear about what exactly you mean when you negate a sentence. So what you do is you switch to negate a statement when you use quantifiers, right? These guys are called quantifiers. We switch there exists with for all and with or. Okay, let's look at an example. So we'll try not to use the word not in each of these examples. Now, I might cheat a little bit on number 1. I might have to use the word like lost or something like that, but let's see. Right, the cheap way to do this, the boring and kind of unhelpful way to do it is just to say, look, I just negated it, right? But that's not very helpful, right? So instead we're going to say, so first of all, I guess you could say, I guess if we used quantifiers here, we could say for all players, I guess you could, we could all say in the set called Giants, there exists some there exists some game such that player has won the game, right? You could say something like that, right? And so to negate this statement, you would change for all to there exists some player on the Giants, and then you could say here, such that for all games, that player has lost the games, right? So if you wanted to negate this statement, you see how we used quantifiers to help us negate this statement, because now the final negation, right, if we just kind of maybe shrink this down a little bit and just sort of rewrite that fully, we could get something like this. There exists a giant such that I guess you could say just there exists a giant who has lost all games. Right? Here's another example, right? There is a solution where every team wins, right? Really what you're saying here is, I guess I'll use purple first. There exists a solution such that every team wins. What you do to negate it is you say, no, that exists becomes a for all. And then every is another word for all, so we just do exists. So let's translate this to English. I guess you could say for all solutions, or we could just maybe English it up a bit and say all solutions have, I could just say have, you could just say some team losing. Right? And last but not least, right, same sort of thing, right? All students at SU. So again, we can just sort of negate this. I might just, to save time, just kind of make it an exist sign, but we're just going to say, right, all students at SU are enrolled in a course in which some student hasn't come to class or hasn't done any homework. So what we can just say to negate this is there exists an SU student such that all courses that student, call it, I'm just going to cheat a little bit. There exists an SU student, column S, such that all courses S is enrolled in have students who all come to class and have done all, or have done, I guess I should say have done some homework. Right? So you see, in addition to, saying, well, like, look, we're going to switch hasn't to has, and hasn't to, has, we change, let me highlight this, right? We change all to exists. We change a course to all courses. We change some student to all students. We change or to and. Okay? So here are some exercises to work on, and that's all for today.